What is up, guys? In this video we're going to go over k-means clustering and how we can use this for unsupervised machine learning. And the first thing I want to go over is the general concept on how this works. So as you can see, it's going to look very similar to our KNN algorithm. We have different groups, and what k-means does is create some markers, and we can specify these markers. As you can see right here, I specified it to be 3 because I want this algorithm to find 3 different groups. And finding the correct number is going to be your only challenge. It really depends on how many features you want to find in the data, because depending on the number you put here, it's going to split up the data into different groups. Right here I decided to choose 3 because I thought that would be the most appropriate for this data set right here. And as you can see, we have an X here, an X here, and an X here. And these are called centroids. So the general idea on how k-means clustering works is that the program is going to generate 3 of these centroids, because we've specified 3, in random locations. And they're not going to be perfectly centered in the data at first. Sometimes they might be outside over here or here, but it's going to go through a certain amount of generations. And each amount of generations, it's going to get closer to the center of those data points. It's going to calculate the distance between here, 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 and everything that is around it, until it gets to the point that it is quite accurate and quite central in respect to all of the data points. So the basic point of k-means clustering is to create groups out of unknown data. And it's actually one of the faster algorithms in machine learning, because it's very simple, and because it's very simple, it can make very fast calculations. But I think that's enough theory for now. Now we can actually go into making our sample program. And we can close that sidebar. And the first thing we want to do is go ahead and import pandas as PD. Then from matplotlib, we want to import pyplot as plt. Then we can go ahead and import from sklearn.cluster. We want to import the k-means. And the first thing we have to do, as always, is create some sample data, and we're just going to call it raw data, which is going to equal a map. And as you can see, I added a comment up here that we're going to be providing some sample data for apples, bananas, and melons. And let's just go ahead and get started with that. So the first thing we want to keep into account is the weight. So we're going to create some fake data that an apple is light, a banana is a bit heavier, and that a melon is the heaviest. So for the apple, we're going to go 1, 5, 2, and 3. And those were the weights of the apples. Then for the banana, we're going to put 10, 11, 15, and 9. And for the melon, we will provide 100, 120, 115, and 116. So there is a incredible increase when it becomes a melon, and a very small increase when it becomes a banana. Next, we want to also specify the sugar content of each. So the apples are going to have a low sugar content because they are smaller. So 262, 200, 100, and 245. Then for the bananas, we will double that. So 500, 520, 595, and 540. And for the melons, we will provide a large sugar count because they are very heavy. So 1000, 1200, 1120, and 1400. And as always, make sure that these two have the same amount of elements, otherwise you will get an exception. Then we want to go ahead and turn this data into a data frame, so PD data frame, and we will insert the raw data. And right now I'm organizing this data, so as you can see, everything is in order from the lightest fruit to the heaviest fruit, but you need to keep in mind that in general you won't have such clean data. And this program is going to be able to organize that, but it's not going to be able to specify what is an apple or what is a banana or what is a melon, because this is unsupervised learning. We're putting random values into the program, and it's just making some correlations and showing us that there is a difference between them, but it's not telling us what they are. But next we have to go ahead and decide how many amounts of clusters we want to provide in the program. And since we know there are 3 different fruits, we are going to say that k is going to equal 3. And again, this might not be so simple if you have lots of data, and you could even insert 5, 10, 2. It really depends on how many groups you want to split the data into. But next we have to go ahead and initialize the model. So we're going to go ahead and type in model is going to equal the k-means model, and we should specify the number of clusters, and I'm just going to provide k. Then we need to go ahead and call model.fit, and we want to fit the data from the data frame. Then we're going to go ahead and get the labels for each one of these groups, and this is going to tell us which group it belongs to, but it's not going to tell us which fruit it is. So let's go ahead and create these labels. So labels are going to equal the model.labels. And so you can understand what that is, we're going to go ahead and print labels and insert the labels. Then we also want to go ahead and generate the centroids, which are going to pinpoint the center of each one of these data groups. So to do that, we just have to go ahead and type in centroids, and that's going to equal model.clusterCenters. Now we're going to go ahead and create a plot, and inside this plot, we want to make sure that we can separate the groups by color. So right now we're going to go ahead and create an array, which is called colors. And inside here, the first color we want to insert is red, followed by green, and finally blue. And in case you have a fourth one, you need to specify some more colors, such as yellow. But 4 colors should suffice, and actually we only need 3 because we only have K as 3 here. But you never know, maybe you want a fourth group, so just add as many colors as you have clusters. So next we have to go ahead and plot all of these values, and we're first going to start by initializing the value of y with 0, and then we're going to specify that for x in labels we want to scatter, so we're going to call our pyplot library .scatter, and we want to locate our data frame at the index of y and 0. And then we're going to do the same thing for y, which is going to be df.locate at the index of y and 1. And the color is going to be set to our colors at the index of x. So each time it plots these values, it's going to go through this iteration and change the color as soon as we get to the next number. And then we have to go ahead and increase y by 1 each time. And that's going to take care of plotting our dots. Now we have to go ahead and plot the centroids. And this is going to be very similar to plotting the labels. So here we're going to go ahead and type in for x in range k. Then we can go ahead and create a variable called crosses. And that's going to equal plt.plot. And inside here, we should plot our centroids at the index of x and 0 and at the index of x and 1. And we are going to set it to a cross that is black. So to do that, we're just going to go ahead and call kx. Then we have to go ahead and type in plt set p, and that's going to equal the crosses. And then we need to specify an ms, which is going to be the length of the crosses. So I'm going to set that to 10.0, and the mu, which is essentially how thick you want the cross to be. And we're just going to set this to 3.0. And finally, all we have to do now is show our plot. So we're going to go ahead and show the plot by typing plt.show. Now we can go ahead and right click on our program and run the program. And I guess it's fairly obvious, but this one right here should not be show, but it should be scatter. And I thought I wrote that, but I guess I didn't. So let's go ahead and rerun the program. And you're going to notice that we're going to get 3 different groups. One's going to be the blue over here, the red over here, and the green over here. So our program successfully identified these 3 groups. Of course, it didn't tell us whether one's a melon or one's a banana or one is a apple, but it was able to detect that there was this pattern between each one of these groups. And let me show you what happens if we go ahead and change the K to 2. You're going to notice that we're going to only get 2 groups identified. And as you can see here, the banana and the apple were classified as one group and the melon was classified as another. So the K value is really going to change the outcome of the algorithm. And also you need to notice that in our labels, it's going to classify one group as ones and one group as zeros. The more K values you have, the higher these numbers are going to be. So if we go back to 3, for example, and run the program again, you're going to notice that we're also going to have the value of 2. So this is classified as group number 2, this is classified as group number 0, and this is classified as group number 1. And once again, this is mostly used to simplify the grouping of random variables, because if you go back to our dataset, you're going to notice that a large majority of datasets are not going to be so organized, and also that each time you run the program, it's going to assign a different group with a different value, which means Apple this time is assigned a 2, but if we rerun the program, the next time it could probably also be assigned a 1 or a 0, and in fact, this time it was assigned a 0 value. So it just calculates very fast the differences and the correlations between the values, and then plots it and finds the best fit for each one of these groups. But anyways, I hope that helped you understand a little bit more about how K-means works. And with that being said, as always guys, if you have any questions or comments, feel free to leave them in the comment section down below and I'll do my best to look at them. Otherwise, with that being said, I will see you guys in the next video.